Hey guys, so today we're going to be talking about titrations, which can be used in a variety of ways. Titrations are used to figure out any particular unknown by comparing the added values to a proportional standard, but is commonly used with solutions to determine many factors like pH or concentration from a solute. Typically, titrations involve an analyte solution or a studied solution and a standard. In our video, we use sodium hydroxide, a strong acid, as our analyte with an unknown concentration. Before you can begin the titration, you must know the concentration and the identity of a standard solution, which in our case was a weak acid, in order to provide a comparison to the analyte. What you're trying to discover in this titration is the equivalence point, or where the moles in one solution is equal to the moles in another solution. It's difficult to anticipate the exact equivalence point though, so we use an indicator to observe the approximate value in the form of a color change. This approximate value is known as the endpoint, which can be detected by a dropwise burette slowly adding sodium hydroxide to your standard solution until you see a color change.
The priming is an important step before the experiment. In order to get accurate measurement, you need to rinse the burette with water 3 times, the solution 3 times. Otherwise, leftover liquid at the tip of the burette will make the measurement slightly less than what it has to be. The priming process was done in our experiment.
In order to determine the concentration of a solution, we need to find the initial and final volumes of the titrant. In order to determine the initial volume of the solution, we simply place some amount of solution into the burette and read the graduations on the burette to 1 degree of uncertainty.
So the initial volume is 4.70.
To release the volume, slowly turn the stopcock to the vertical position while swirling the reaction vessel holding the analyte. Continue to titrate the solution until it turns light pink. Once the solution is turned pink, turn the stopcock to a horizontal position to stop the flow of the solution.
Wait, it might be pink.
Wait, put it down.
It's pink. It's pink. It's perfect. Wait, so we can try and look at it?
Is this pink?
Yeah, that's pink.
To read the final volume, read the graduations on the burette to 1 degree of uncertainty at the viscous.
Final volume is 29.10.
Hello, my name is Dr. Today,
We're recording the initial volume and the final volume together.
the data we collected is from exercise 1. All of the data is recorded to decimal points. The reason why we record this data is to determine the concentration of acid and soda. The reason why we have 3 trials is because KHP dissolves slowly in water, and so each trial has a different amount of sodium hydroxide needed to titrate. Concentration is moles over volume, so we had to also record the mass so we can use the mass to determine the number of moles in the solution. We also have final and initial volumes because we filled up the 50 milliliter burette to a certain point, recorded that volume, and then let it go down to enough to where it would titrate, and then recorded that volume. We also let it be noted that we stopped at the 50 milliliter mark because to go past would result in inaccurate volumes.